I believe some pilots have heard of the concept of magnetic saturation, as well as why some high kV motors might burn out under high throttle conditions when paired with larger propellers. Today I can provide an explanation for you guys. As you may know, during motor design, we conduct bench tests. These bench tests provide current curves, thrust curves, throttle to thrust, and power to thrust curves, allowing comprehensive motor evaluation. They measure a motor's static thrust performance. We often observe that motors with improper kV values experience sudden current spikes at full throttle. During these spikes, the thrust doesn't increase as it does in the lower throttle range 0 to 50%, where thrust rises with current. In the high throttle current surge range, thrust actually plateaus or even decreases. When this occurs, we say the motor has reached magnetic saturation. But why does this happen? As mentioned previously, a stalled motor produces maximum torque, meaning maximum current, at 0 RPM. With a propeller, the situation changes completely. At lower speeds, the propeller requires less torque. But at higher speeds, air resistance increases, demanding more torque from the motor. This means that current increases with speed. At these high speed, high torque conditions, increasing kV effectively increasing voltage pushes the motor further. However, the motor's electromagnetic design, determined by core material, magnets, and stator rings, has limited flux capacity. A given motor size can only handle so much magnetic flux. When saturated, more voltage won't increase speed because torque has peaked. The gap between input voltage and back EMF widens significantly. Normally, back EMF matches input voltage, leaving little voltage across the coil. But when saturated, back EMF stops rising proportionally. Continued voltage input creates a large potential difference. This excess voltage turns the coil into a heating element. The resulting current spike burns out the windings. Higher current heats the coils, increasing resistance, which may then reduce current. This explains why improper kV or propeller matching like overly large pitch causes burnout. Improved materials and specialized magnetic circuit designs can enhance flux capacity and performance limits. This allows high speeds while maintaining torque. Of course, simply using a larger motor also works well, but racers avoid this due to added weight and power consumption. That concludes today's explanation.